All right. Hey, everybody. We are in lesson 10.3 on arcs and chords. Okay, so we have learned what an arc is. We need to talk about what a chord is. So a chord is basically a segment whose both endpoints are on the circle. For you visual people, F, G is a chord. J, H is a chord. You can call it GF if you want to, or HJ, doesn't really matter. You need to know that a diameter is a chord, but it's a very specific type of chord because it goes through the center. That's a diameter. All right, let's see. Oh, okay. Oh, yeah, you need to know if you've got two chords that are equal, then their arcs are equal. So let's say that the chord FG is congruent to the chord JH, then the arc from F to G and the arc from J to H are going to be equal to each other. So you need to know that's this theorem right here. And vice versa, by the way. If their arcs are congruent, then the chords are congruent. Okay, I also need to know that when a radius and a diameter are, that is not a diameter, that's a chord, my bad. A radius and a chord intersect each other at a perpendicular angle. That means 90-degree box. It bisects. It bisects the chord. So I'm saying Z to X and Z to Y are going to be equal to each other. And the arc X to B is going to be congruent to the arc YB. So when you see a little perpendicular, a couple things happen. It's been bisected. The chord has been bisected, and the arc XY has been bisected by B. Okay. Okay. Same thing as a diameter, same thing as a radius, or radius. What else we got? Go to the next page of your workbook. Okay, so let's see. I'm on page 588 of your workbook. Same circle, congruent circles, chords congruent if and only if they're equal from the center. Okay, so if it's perpendicular and these are the same distance from the center, like LX is congruent to LY, then these two chords are congruent, F, G, and JH. You know what? Let's get to example. Example number 1. All right, it says JK's chord is congruent to LM's chord, and they are marked equal, as you can see. All right. The arc, or the measure of arc LM, is 75. Find the measure of arc JK. Well, it's going to be 75 because they're equal to each other. All right, so JK and LM are congruent chords. So the corresponding arcs, JK and LM, are congruent. And that means that they are 75 degrees. Okay, check for understanding. All right, we got chord AB congruent to chord CD. If the measure of arc AB is 60, then the measure of arc CD is 60 degrees. They're equal to each other. And this is the rule. The theorem over here says that they're going to be equal to each other. So, yep, they're the same. They're congruent. Their arcs are also the same measure. All right, let's move on. All right, example number 2 at the bottom of page 588 on your workbook says use congruent arcs to find chord lengths. Okay, well, first off, these arcs are marked equal. It's that little 1 slash and this little 1 slash. They're equal to each other, which means the chords ED and FG are equal. So you're going to set them equal to each other. 2x plus 6 for chord DE equals to 5x minus 9 for chord FG. All right, they want to subtract 2x for each side. That's going to leave 6. 5x minus 2x is 3x. Bring down your minus 9. All right, they want us to add 9 to the other side. So we're going to take 6 and add 9 to it, and it gets us 15. And that equals, 15 equals 3x divided by the 3, and that means 5 equals x. Okay, Now we need to do a little plug and chug, and they want us to find FG. So after we find X, we're going to take X out of the FG. By the way, it really doesn't matter which one you plug into. I mean, technically, it's asking for FG. But if you happen to have students that plug it in to the 2X plus 6, remember, they are going to be the same answers. And that's a really good way to have your students check their work. So 5 times 5 is 25. And 25 minus 9 is 16. So if they happen to want to check, just have them plug in over here. 2 times 5 is 10 plus 6 is 16. If they get the same answers, they know they did it right. All right, we have a check. I'm on the bottom of page 588 of the workbook. We are definitely going to set those two things equal to each other because their arcs are marked equal, which means the chords are equal to each other. Okay, so I'm going to put 5x minus 9 equals 2x plus 3. All right, I'm going to subtract 2x to the other side. 5x minus 2x is 3x. Bring down my minus 9 equals 3. I'm going to add 9 to the other side. So I'm going to add 9 over here. And 3 plus 9 is going to be 12. And then the opposite of multiplying by 3 is to divide by 3. So 12 divided by 3 equals 4. Now, I believe they actually want me to plug this in to RS, but it's going to be a 4 that I plug in. 5 times 4 is 20, and 20 minus 9 is an 11. If you happen to plug it in here, 4 times 2 is 8. 8 plus 3 is 11. So if you want to have your students check. Or, hey, if you're one of my students, that's a good way to check. All right, moving on to page 589 of your workbook, example number 3. Okay, well, I see a little perpendicular here, which means the rule says that EH will be congruent to GH. So if EH is 3.5, and it doesn't say in my directions, but that means GH is 3.5. All right, so let's get to our directions. All right, circle D, that means D is the center. Arc EFG is 120 degrees. We need to find arc FG, which has been bisected by the rule. Bisect means cut in half. And we need to find EG. All right, well, that means they want all the way across. Well, okay, one thing at a time, I suppose. All right, so first off, arc EFG is 120. Now, this perpendicular right here means that the radius and the chord are perpendicular. That means that arc EFG has been cut in half. So it's going to be 1/2 of 120 is 60 degrees. Okay. Now, because EF's arc and FG's arc are congruent or equal to each other, EH is 3.5. Doing these out of order, my apologies. Which means GH is 3.5. And that means if I multiply 2 times 3.5, I'll end up with the entire EG. Well, 3.5 times 2 is 7. So from E to G is 7 because 3.5 on the left plus 3.5 on the right is 7. All right. Okay, we got a check right below that on page 589. All right, so it says PQR is 90. Well, 90 divided by 2 is 45. So PQ is going to be 45 degrees. All right. Now it says from T to R is 6, and they want us to find PR. Well, if T to R is 6, that means T to P is 6. 6 on the right plus 6 on the left is 12 units. And there's your check. Okay. Same page of your workbook, example number 4. Looks like we have a little word problem. We got a record shown that can be modeled by a circle. The diameter of CD, E being the center, so it's a diameter because it goes through the center. CD is 12, which means CE is 6. ED is 6, by the way. Go ahead and put that in. All right. The chord FH is 10. Okay, well, I see a little perpendicular box there, which means the diameter and the chord form a 90-degree angle. That means that FH chord has been bisected. It means cut in half. So if F all the way to H is 10, then F to G is 5, and G to H is 5. Now, I'm not sure if that's what they're asking, but, oh, it is. Oh, boom, there it is. Half of 10 is 5. Okay, well, let's go through here. CD, they said is 12. I already got ED is 6 because that's a radius. A radius is half of a diameter. All right, all radii of a circle are congruent, so EF is 6. Because the diameter CD is perpendicular to FH, it bisects it. I said that a minute ago. Okay, we're cool there. All right, step number 3. Use the Pythagorean theorem to find EG. Okay. So they want me to find EG. Well, E to F is 6 because that's a radius. And we just found F to G is 5 because F to H is 10. And it's been bisected, so it's 5. So we're going to do the Pythagorean theorem with 5 squared plus x squared, or EG squared, equals 6 squared. All right, so 5 squared is 25, 6 squared is 36. Subtract 25 to the other side. So 36 minus 25 is an 11. And then the opposite of squaring is the square root of 11. The following students to bring their Chromebooks and their belongings and come to room 117 around the circle. Malia Johnson. All right, so the square root of 11. Hannah Johnson. Looks like it's about 3.3. Tyra Balton. Eric Washington. All right, we got to check. All right, I'm going to pause this for a second because they're doing makeup testing. Give me just a second, you guys. All right, sorry about that. EOC makeups. All right, so let's see. Okay, I turned the page. I'm on page 590 of your consumable workbook. All right, it says steering devices provide drivers with more control and strength when turning a steering wheel. A technician installing a steering device at point P. All right, on the steering wheel shown. The steering device extends to point T. All right, right there. They're talking about this right here. And the diameter of the steering wheel is 15 inches long. All right, so from Q to P is 15. Divide that in half, and you'll find the distance from R to P and R to Q. So 15 divided by 2. All right, so the distance from R to P is 7.5. The distance from R to Q is 7.5, which means if I were to draw a line from R to S, it would be 7.5. Okay, the chord SV, that's this one, S to V, is 12 inches long and perpendicular. Okay, what is the length of the steering device? Okay, so let's see. So S to V being the chord is 12 because it's perpendicular. That will also be bisected. That means cut in half. So S to T is going to be half of 12, which is 6. And T to V will also be half of 12, which is 6. Okay. So let's see. They're looking for this distance right here from P to T. Well, in my last problem, we did the Pythagorean theorem using triangle SRT. And what that would give us is the distance from R to T. Now, this one's a little bit more, an extra step. We got to do a little subtraction because they want P to T. All right, so first off, I'm going to do the Pythagorean theorem with triangle TSR. Now, we already know that S to R is a radius. So that is going to be, again, 7.5 because that's half of 15, 7.5. We know that S to T is 6 because that is half of your chord. Half of 12 is 6. So we're going to do the Pythagorean theorem with a squared plus 6 squared equals 7.5 squared. And for you visual people, I'll go ahead and write that out. So a squared plus 6 squared equals 7.5 squared. Okay, I'm going to subtract 6 squared to the other side. I'm going to use my calculator to do this. So 7.5 squared in my calculator minus 6 squared in my calculator is 20.25. So I just subtracted 7.5 squared minus 6 squared. All right, the opposite of squaring is to square root. So that's how you get rid of a square. So I'm going to do the square root of 20.25, and I get 4.5. So remember now, this is not my final answer. What we just found is the distance from R to T. R to T. Now, you guys, they want the distance from P to T. Okay, so if we know that R to P, which is the radius, R to P is 7.5. That's your radius, R to P. And we now know that RT is equal to 4.5. How do you find P to T, the rest of it? In other words, 4.5 and what is 7.5? So we're going to subtract those, and that's going to give us PT. So 7.5 minus 4.5 is going to be 3, and that's your answer. PT is a 3. So sometimes it's not a difficult problem, but there's one extra step. You got to really pay attention to what the problem is asking for. If you're a brand new teacher, day one, I tell my students, listen, if you've ever had a word problem, you've read it again, and you still don't understand what it's asking. That is the hard part about geometry, is what in the world are they telling me? What in the world are they asking? So take your time, talk it through. I teach my students to talk through things. All right, example number 5. Okay, we're on page 590 still. All right, we got PQ, that's the chord, is 3x minus 4. And since I see perpendicular and T to H is 8 and U to H is 8, I'm going to say that these chords are equal. And R to S is 14 to find X. So we're going to set them equal to each other. I'll put 3x minus 4 equals 14. All right, I'm going to add 4 to the other side. So 3x, 4 and 14 make 18. And then the opposite of multiplying by 3 is to divide by 3. 18 divided by 3 is 6. Okay, so there we go. There is our x. All right, got to check, and we need to find PG. Okay, let's see what we got here. Okay, we got circle P, CE, which is a chord, is congruent to FH, which is a chord, and they're both 48. Okay, so if the chords are equal, that means the distance from the center to that chord, being that their perpendicular angles are equal to each other. So we're going to set these two things equal to each other. And again, if you're having a hard time wanting to know why, it's because the theorems that we talked about at the beginning of the lesson says that when things are congruent to each other, they're equal to each other. So I'm going to set this equal. All right, so I'm going to subtract 3x to the other side. So 6x minus 3x is 3x. Bring down my minus 3 and my equal 6. The opposite of subtracting 3 is to add 3 to the other side. So 6 plus 3 is 9. And the opposite of multiplying by 3 is to divide by 3. 9 divided by 3 is 3. Now remember, we are not done because they wanted us to find PG. But that is what we are plugging in to find PG. So we're going to take our 3 and plug it in to the 3x plus 6. All right. Take this x out, replace it with the 3. 3 times 3 is 9. And then 9 plus 6 is 15. So P to G is 15. And again, if you're a student, and you want to check to make sure this is right, you can also plug it into the 6x minus 3 to make sure it comes out to be also 15. If it does, you know you did it right. If it does not, something's not right. Go back and try and figure it out. All right, if you're a brand new teacher, somewhere along the way, because when they say a degree, see a degree sign on some of these problems, they think that they're actually angles, and you might have to remind them that they do not add up to be 180. So please keep that in mind if you're a brand new teacher. Remind them that just because it doesn't, or just because it has a degree sign being an arc, it's not the same thing as an angle. And besides, it has to be a triangle to be a 180, and these are, or supplementary angles. All right. So I am done. If you guys have a question, let me know. Ask me. Ask your teacher. Guys, I'm happy to help. You guys have a great day.